RJ45 Connector. An RJ45 connector is the standard, 8-pin plug used to terminate Ethernet cables, providing the physical connection for wired networking between devices like computers, routers, switches, and game consoles, enabling data transfer for LANs and Internet access. It's slightly larger than a phone jack, RJ11, and allows for high-speed data signals over twisted pair wires, adhering to standards like T568A/B for proper function, often called Cat5e, Cat6, etc., based on cable performance. Key functions and features. Standard interface offers a consistent way to connect Ethernet network cables. 8P8C stands for 8 positions, 8 conductors, meaning it has 8 pins, though not all are always used in older standards. Device connectivity connects PCs, servers, smart TVs, routers, and gaming consoles to networks. Twisted pair cables carries data over cables like Cat5e, Cat6, etc., which have twisted wire pairs to reduce interference. Wiring standards T568A and T568B are common color codes. T568B is popular in the US, but both ends of a cable must match, or be a crossover cable. How it works: 1. Cable preparation. The 8 wires inside an Ethernet cable, example Cat6, are stripped and arranged in the T568A or T568B order. 2. Insertion. The wires are carefully inserted into the RJ45 plug. 3. Crimping. A special tool crimps the plug onto the cable, pushing the pins through the insulation to make electrical contact with the wires. Usage and applications. RJ45 connectors are essential for creating wired network connections in a variety of environments, home and office, connecting computers, smart TVs, game consoles, and printers to modems or routers. Industrial settings, ruggedized and waterproof versions are used in factory automation and control systems that may be subject to harsh conditions. Power over Ethernet. Many RJ45 connectors and systems are designed to deliver both data and electrical power over the same cable to compatible devices like security cameras or wireless access points, eliminating the need for separate power sources. Wiring standards. For an Ethernet cable to function correctly, the internal wires must be arranged according to one of 2 industry standard color coding schemes, TIA/EIA568A or TIA/EIA568B. T568A and T568B specify the exact order in which the 8 wires connect to the pins. T568B is more commonly used in the US, but both are functional. Straight-through cables, patch cables, use the same standard, A or B, on both ends and are used to connect different types of devices, example a computer to a router. Crossover cables use T568A on one end and T568B on the other and were traditionally used to connect 2 of the same type of devices, example 2 computers directly. Common types of RJ45 connectors. Shielded, STP feature metal shielding to protect the data signal from electromagnetic interference, EMI, in electrically noisy environments. Unshielded, UTP lack the extra shielding and are suitable for most standard home and office applications. Pass-through, designed to allow wires to be pushed completely through the connector body for easier alignment and trimming. Tool-less, can be terminated without a crimping tool, often using a pressure mechanism to secure the wires. The T568B wiring standard for an RJ45 connector, which is the most common in the United States for commercial and residential networks, has the following pin assignments from pin 1 to pin 8. Pin wire color signal function number 1 white/orange transmit data, plus, 2 orange transmit data, 3 white/green receive data, plus, 4 blue unused/PO 5 white/blue unused/PO 6 green receive data, 7 white/brown unused/PO 8 brown unused/PO. This configuration uses the orange pair for transmitting data and the green pair for receiving data in 10/100 Mbps Ethernet. 4 gigabit Ethernet, 1000 Mbps and faster, all 8-pin/wires are utilized. Automatic crossover wiring in Ethernet. A crossover cable is a specific type of Ethernet cable designed to directly connect 2 devices of the same type without the use of an intermediate networking device like a router, switch, or hub. Unlike standard straight-through patch cables, the wiring inside a crossover cable is intentionally crossed over or reversed on one end. How crossover wiring works. The fundamental principle of Ethernet communication is that a device transmits data on one pair of wires and receives data on a different pair. When connecting 2 similar devices, example 2 computers or 2 switches, they both expect to transmit data on the same physical pins, pin 1 and 2, and receive on the same pins, pin 3 and 6. If you connect 2 computers with a standard straight-through cable, the transmit signal from computer A goes to the transmit input on computer B, and neither device receives anything. The crossover cable solves this by taking the wires used for transmitting on one end and crossing them over so they align with the wires used for receiving on the other end, and vice versa. T568A versus T568B implementation. To create a functional crossover cable, you terminate the 2 ends of the cable using different wiring standards. End 1 is wired to T568A standard. N2 is wired to T568B standard. This combination ensures that the critical transmit/receive pairs are swapped, pin N1, T568A, N2, T568B, function 1 white/green, TX plus, white/orange, RX plus, crossed over 2 green, TX, orange, RX, crossed over 3 white/orange, RX plus, white/green, TX plus, crossed over 6 orange, RX, green, TX, crossed over 4, 5, 7, 8 blue/brown pairs unchanged. Modern relevance, Auto MDI/MDIX. In modern networking, the need for physical crossover cables has largely disappeared. Most contemporary Ethernet ports, found on modern PCs, laptops, routers, and switches, feature a technology called Auto MDI/MDIX, Automatic Medium Dependent Interface Crossover. Devices with Auto MDI/MDIX automatically detect the wiring configuration of the connected cable and internally reconfigure their ports as needed. This means you can almost always use a standard, readily available straight-through patch cable for any connection type, and the equipment will sort out the transmit and receive pairs automatically. Crossover cables are primarily found today in legacy hardware systems or specific industrial applications where older equipment lacks the auto-sensing capability. Automatic Medium Dependent Interface Crossover, Auto MDI/MDIX, is a feature found in modern Ethernet devices that eliminates the need for specific straight-through or crossover cables. Instead of requiring a user to determine the correct cable type for a connection, the device's network port automatically detects the wiring configuration and adjusts its internal transmit, TX, and receive, RX, signals accordingly. How Auto MDI/MDIX works. The mechanism is a function of the physical layer, PHY, chip within the networking device and operates automatically during the link initialization phase, often in conjunction with the broader auto negotiation process. One-link detection: when a cable is connected and the devices are powered on, the network ports exchange signals to establish a link. Two-signal sensing: the Auto MDI/MDIX circuitry within each port's PHY chip sends out special link pulses called fast link pulses, FLPs, which contain information about its capabilities. 3. Configuration check: the devices listen to the incoming signals to determine which pins the remote device is using for transmission and reception. If a device expects to transmit on pins 1 and 2 but detects an incoming signal on those same pins, it identifies that a crossover is needed. If the transmit/receive pairs align correctly, as they would when connecting an MDI port to an MDIX port with a straight-through cable, no change is necessary. 4. Internal switching: the device with Auto MDI/MDIX capability will then internally reconfigure its port logic, using an internal switching circuit, to swap its transmit and receive pairs, effectively applying an internal crossover, to match the configuration of the device at the other end of the cable. 5. Link establishment: once the transmit and receive channels are correctly aligned, the link is established, and normal data transmission begins. The following Ethernet standards generally support or require automatic crossover, Auto MDI/MDIX, capabilities in modern equipment: mandatory Ethernet speed Auto MDI/MDI Note Standard, MBPs, X optional. Vendor early implementations often required a physical 10-T10 specific, crossover cable for like device connections. Optional, vendor similar to 10-T, the feature was optional but 100-TX100 specific, widely adopted in later hardware. Auto MDI/MDIX is an integral part of the Gigabit 1000, 1000-T required Ethernet standard, IEEE 802.3 AB, making crossover GBPS cables virtually obsolete for these connections. 2500, 2.5 part of the IEEE 802.3 BZ standard, it leverages Auto 2.5-T required GBPS, MDI/MDIX for connectivity over Cat5e/Cat6 cabling. 5000, 5.5-T required also part of the 802.3 BZ standard. GBPS, 10,000, 10 as with all modern multi-gigabit standards, automatic 10-T required GBPS, crossover is a fundamental feature. Summary: while Auto MDI/MDIX was an optional, vendor-specific feature for older 10-T and 100-TX, fast Ethernet, devices, it is a mandatory component of the specification for all Gigabit Ethernet, 1000-T, and faster twisted pair copper standards. This ensures that any modern networking equipment supporting these speeds can use a standard straight-through Ethernet cable for any connection type.